So today in Pre-Calculus 12 we are going to start chapter number 3, and this is all on transforming graphs of functions. Today we're doing chapter 3.1, translating graphs of functions, and we're also going to do some review on parent functions as well. So we've got two goals for today. The first one is to review the parent functions, and then the second goal for today is to investigate horizontal and vertical translations of graphs, which will be a little bit new. So before we get into the translations, I just want to go through the parent functions. First parent function that you'll probably recognize is f of x equals x. This is our linear function. So if we want to draw a linear function where y is equal to x, we can come up with a table of values. We can come up with a few points. I'll choose, so let's say, -3. That means y will be -3. So y equals x in this case. 0, y is equal to 0, and 3, y is equal to 3. So we'll go ahead, we'll graph those points, and we'll connect the lines. So 0, 0, 3, positive 3, -3, and -3. There's 3 points on our graph. We've got enough information there where we can connect them with a straight line, and we've got a line that goes through all of those points and continues in either direction. So this line will actually go up and over. So there's the parent function of our linear function. Second one that we'll try is with a squared function. So with this one we've got f of x is equal to x squared, or y is equal to x squared. So if we choose -3 in for x here, -3 squared is 9. So there's my value of y, 0 and 0. And then 3 squared is also 9. So there's some points for our squared function. So we go over 1, 2, 3, and up. 1, 2, 3, 4, 5, 6, 7, 8, 9. Should have chosen a point on the graph. And same thing over in this direction. So you can see with these ones, we're not connecting with straight lines this time. And these lines will go on indefinitely in there. We've got a vertex at 0, 0. So there's with the squared function. Next one we'll try is with a cubic function. So with this one we'll include a few more points. Let's try x is equal to -3. -3 cubed this time is -27. -2 cubed is -8. -1 cubed is -1. 0 cubed is still 0. 1 cubed is 1. 2 cubed is 8, and 3 cubed is 27. I've got some points that won't appear on our graph, but that's okay. So we know we've got a 0, 0 here, -1, -1, -2, -8. 1, 2, 3, 4, 5, 6, 7. This one's just not appearing on our graph. Same thing in the other direction. So my graph this time is looking like this, and it's going to continue in either direction. It should go through that point. Okay, cubic function. This time, and we investigated this square root function in the last unit. So if we take the square root of x, first off, if you take a look, what happens when we're trying to take the square root of a negative number? Well, in this case, it doesn't exist. So we're just going to put a blank there. We have no value of y when x is equal to -1. X is equal to 0. The square root of 0 is 0, so that one works. Square root of 1 is 1. Square root, I'm going to pick some easy values here. Square root of 4 is 2. Square root of 9 is 3. So this graph is going to start right here. Once we go up to x is equal to 4, y is equal to 2, and 2, 3, 4, 5, 6, 7, 8, 9. Y becomes 3 around this point. So there's a square root function. Okay, the next one, the absolute value function. This one is a bit new. You did cover it before, but we haven't looked at it yet in this class. We'll start, if we take x is -3. The absolute value of -3 is +3. So there's our y value. -2, 2, -1, 1, 0, absolute value 0, 0, 1, 1, 2, 2, 3, 3. So all I'm doing with my x term is making it positive. So I'll go ahead and graph that one. So with this graph, you'll notice that we have straight lines this time going in both directions. So here's my last function here, my last parent function. This one should look familiar. It's a rational function. For this one, we've got f of x is equal to 1 over x. So with this one, we know we've got a couple of non-permissible values. We've got a non-permissible value of x. X cannot equal 0 in this case. So we're going to have a vertical asymptote. And the equation of that vertical asymptote is x equals 0. So in my equation, if x had equals 0, we'd have 1 divided by 0, and we can't do that. So we're going to draw our asymptote into this graph. And because the power of x is bigger on the bottom than on the top, we're also going to have a horizontal asymptote. And the equation of that horizontal asymptote is y equals 0. So we'll draw that one in as well. Now that we've got our asymptotes in place, we can pick some values of x on either side of the vertical asymptote and do some trial points. Sorry, I lost my screen here. Okay, we'll try x is equal to -1, -2. So if we have 1 divided by -1, y is equal to -1. 1 divided by -2, y is equal to -1/2. On the other side, if we try x is equal to 1, 1 divided by 1 is 1. X equals 2, 1 divided by 2 is 1/2. So we've got some points to plot on this graph. So on the left-hand side of our graph, oops, my graph is going to be approaching both of these asymptotes. On the right-hand side of my graph, same sort of thing. So there's the parent function. Now we're going to try and put this together with some translations, how those parent functions are translated. So first off, just with translating a graph, if I've got this graph here, I've got a square or a rectangle here, and I know one of the coordinates is at 3 and 1. If I want to translate that graph 2 units to the right and 1 unit up, I'm going to add 2 to the x-coordinate and add 1 to the y-coordinate. So my new vertex here is going to be at 5 and 2. And the rest of the dimensions of that box are going to stay the same. So along the bottom, 2, and going up 3. So there's a translation. Now the question is, can we write an equation that shows this translation without having to actually graph it? So we're going to try it with this parent function. So if we have y is equal to the square root of x, and the translation y plus 1 equals the square root of x minus 1, what happens to that graph? Well, let's give it a shot. Let's try it on our graphing calculators. I'm going to graph both of these functions. I'm going to start with the first one. Okay, so you can see here, I'm going to graph just square root of x. And then on the same graph, I'm going to do the translation. Y plus 1 equals the square root of x minus 2. Now this one's a little bit trickier to see because we're going to actually have to move this plus 1 over to the other side so that we can enter it into our calculators correctly. So I have y is equal to the square root of x minus 2 minus 1. We'll try graphing that one in our calculator at the same time. So I'm just going to turn this one on. So there's my original function, y equals the square root of x. And here's my translated function, y equals the square root of x minus 2 minus 1. Now if you take a look at this function, what's happened to it is my x value is moved over 2. You can see that there was my original point. My new point where this is starting is at x is equal to 2, and it's moved the function down 1. So we can make some generalizations about this. Okay, see if we can pick up some patterns. So x is translated 2 to the right, y is translated 1 down. So it's pretty much the opposite of what I had in my original function. Y was translated 1 down. Well, we had 1 up here. X is translated 2 to the right. This is minus 2. So we're doing the opposite of what it's telling us to do in this original question. Let's see if that pattern still holds. So we'll try this one right here. We've got y is equal to 1 over x, or y plus 5, or y minus 5 is equal to 1 over x plus 3. So if we write our predictions, what we predict is going to happen here. I'm going to predict that x is translated. Now this time, when we had minus 2, it was translated 2 to the right. This time I've got positive 3. I'm going to guess that we're going to go 3 to the left. Okay, we're going to do the opposite of the sign. And y is translated 5. And we're going to do the opposite of this negative 5. So I'm going to say 5 up. So let's try graphing this one and see if it holds the same sort of pattern. Clear my old values in here. So to get my parent function, y is equal to 1 over x. So just double checking, here's what my parent function looked like, what we predicted before. And this time we're going to go, and when we graph this, we're going to do 1 over, I'm going to put x plus 3 in brackets. Okay, 1 over, in brackets, x plus 3, close brackets, and then I'm going to add 5 because I'm going to bring the 5 over to the other side. So let's take a look at what this function looks like. So you can see I've moved my function 3 to the left, and I've moved it 1, 2, 3, 4, 5 up. So my prediction holds true. So to take this over one step, how could we change the parent function y equals the absolute value of x to shift it 4 down and left 5? So if we want to go 4 down, remember that down corresponds to the y values. So I'm going to go y plus 4, I'm doing the opposite, equals, and I'm going to do the absolute value of x, and if I want to go left 5, the opposite of that is going to be plus 5. I'm going to put that in my absolute value sign. So we'll do a check, we'll make sure that I was correct here. What we're going to graph is, we're going to graph the parent function, y equals the absolute value of x. We're going to graph my translated function, y equals the absolute value of x plus 5 minus 4. And we'll see if this holds true. Okay, to do an absolute value in here, we're actually going to have to hit our math button and go down to find absolute value. Oops. Okay, we find it under the number tab, so absolute value is right here. So absolute value of x. And the next one, I'm going to do math. I'm going to go over 1 to number. Absolute value of x plus 5 minus 4. So I'm going to graph those two functions. There's my parent functions. And my new function, my translated function, you can see is 5 over to the left and 4 down. So our prediction works. So as a generalization, we can generalize this, that if the parent is y is equal to f of x, my translation is going to be y minus k equals f of a minus h. And this value of k corresponds to my vertical translation. and the value of h corresponds to the horizontal translation. And that concludes our lesson for today.